last thing we're going to do in 8.5 is find the magnitude and the direction of a vector. We have already talked about the magnitude, the length of the vector. You already know how to find the length of the vector. That's by using the Pythagorean theorem. The direction of the vector, that's just the smallest positive angle in standard position formed by the positive x-axis and the vector. So let's look at that visually. Alright, so if I've got some vector, it's going to be, I'm looking at, so what they're asking me to do is find the length, magnitude of V. Alright, and they're also asking me to find the positive smallest angle that's formed by the positive x-axis. We know that an angle is in standard position if it starts at the positive x-axis. And so I'm looking for theta here. Well, if I'm looking for theta, right, and I know if I'm given a vector and I know component form, remember I'm going to know A1, the horizontal component, and I'm going to know A2, the vertical component, right? And I know how to find this third side. Alright, so the magnitude is going to be the square root of A1 squared plus A2 squared. We've already done that. How am I going to find theta? Well, if I'm given A1 and A2, this isn't anything different. It's just got different variables. A1 is adjacent, A2 is opposite adjacent. We're going to use the tangent function, so the tangent of theta is going to equal A2 over A1 in this case, right? And we've looked at this before. We looked at it with complex numbers. We had B and A. We looked at it with rectangular coordinates. We used Y and X. Okay, so this is nothing different. Think about just visualizing your right triangle and you can figure out what's going on here. Alright, so magnitude we know how to find. Now we know how to find the direction of the vector because that's our angle. So let's do a couple of these examples. So let's find the magnitude of this thing first. We know that is the square root of negative square root 2 over 2 squared plus negative square root 2 over 2 squared. Alright, so we've got 2 over 4, 2 over 4, or 1/2 plus 1/2. Square root of 1 is, that's not a plus, that's an equals 1. Alright, so that's the length of that thing, and then we want to find the direction. Angle, that's theta. Remember, if we're looking for theta, we're doing the vertical over the horizontal. So we've got negative square root 2 over negative square root 2 over 2. You wouldn't really need to write that out because you know when you divide anything by itself, it's 1. Alright, anytime we're looking for theta, what do we have to take into consideration? Okay, you should have automatically said what quadrant we're in. Alright, so if I'm starting off in standard position and I go to the left and then down, I'm in quadrant 3. Right? Quadrant 3. So my angle's coming out of quadrant 3. What's my reference angle here? You know your reference angle. I'll just put a little thing. Is 45 degrees, which means your theta here is going to be 180 plus 45 degrees, or 225. Alright, so the magnitude was 1. Oops. And the direction was 225 degrees. Now, let's just, for my sake, verify this. So I don't have much room left here, but I'm gonna just do this. Alright, if I graph this thing and I went about 0.7 to the left and about 0.7 down, I'd be right there. So my vector was right there. Alright, this was asking for the length of this vector, the magnitude of this vector, and we found that to be 1. And it also asks for the smallest angle starting at the positive x-axis, and that was 225 degrees. Alright, let's do another one of these. Alright, this one is in the form I plus j, so you can leave it like that or write it in component form. I'm going to write it in component form. My number in front of I was 1, number in front of j was 1. Alright, the magnitude is going to be 1 squared plus 1 squared or the square root of 2. That's the length of that vector. Alright, the direction of this vector is going to be 1 over 1. My reference angle is again 45 degrees. This is in quadrant 1. So my theta is 45 degrees. That's the direction. That's the magnitude. Alright, let's do one more. One more example. So I've got, my vector is 3, 4. So my magnitude is going to be 3 squared plus 4 squared, which is 9 plus 16, or 5. That's my magnitude. This one, we've got tangent of theta equals 4 over 3. Alright, quadrant 1. My horizontal is positive, vertical is positive. Alright, so I'm going to have to use my inverse function here just to approximate this angle. Remember in an earlier section when we had something like this, we couldn't approximate, we had to leave it written just like that. Here you can approximate, so I'm going to use my inverse tangent of 4 divided by 3. And if this were not in quadrant 1, then you would still use the inverse tangent of 4 over 3 and get your reference angle, and then use your reference angle to find the angle in whatever quadrant it's in. In this case, I'm in quadrant 1, so I am using my reference angle, so it's about 53.13 degrees.